All right, we're going to start off by just labeling the unit circle in degrees. So you've got 3 circles on your page. This one's going to be strictly about the angle measures in degrees. So 0 degrees would be first. I'm going to hit the quadrantals first. Actually, I'm going to use black for that. Okay, so I went up to this top one would be 90. Then over here would be 180. Then down here 270. Sometimes it's convenient to go by patterns. That's why I'm doing it this way. So I'm going to kind of show you a pattern for them. This is 30 degrees. If I went another 30 degrees, I'm actually skipping this line in the middle, okay? Because that one's going to be 45. And then the next one's going to be 60. So those are our special angle measures that we want to know and they are our reference angles for all of the other places around this circle. If you'd like to, you can. I'll try to mimic it for the main thing's going to be when we color the entire unit circle, okay? So if you don't have to really color this one, I'm just going to start to get you to see it. Okay, so if I went another 30 degrees, I would be at 90. And then if I went 30 more, I'd be at 120. And that would actually be a reference angle of 60 with the x-axis, because it's 60 more degrees to get down to here. Then if I went to the next one, I'd go 30 more. I skip the middle one. And I go 30, added on to 120 is 150. 30 more is 180. Another 30 would be 210. And then I would be skipping the middle one and go another 30 to get to 40. And then 30 plus 240 is 270. And then the next one would be 30 more, or 300. And then the one after that would be 330. Okay, finally I'm going to do all my reference angles of 45 degrees. Every one of these next ones are 45 into the quadrant, whichever way you want to look at it. So if I do 45 plus 45, I'm at 90. Another 45 would be 135. If I added 45 to that, I'd be at 180. Add 45 to 180, get 225. Add another 45, you'd be at 270. 270 plus 45 would be 315. Notice that these are 15 apart within the area, like inside of here. Okay, they're 15 degrees apart between these. Okay, another thing to maybe notice. All right, now we're going to go in radians. Okay, so in radians, 30 degrees is pi over 6. Let's say you didn't remember that. Remember our conversion factor was times pi over 180. And we found that that would reduce to pi over 6. That's this one. All right, so we got pi over 6. And then we're going to keep counting by 30s just like we did in the last one. But we're going to count in terms of pi over 6s. Okay, so we have 1 pi over 6. 2 pi over 6. Now wait, I'm not going to label that because I can tell that it's going to reduce. So that's actually pi over 3. All right, now I have multiple ways I can teach this. It might be better if you didn't want to keep on trying to reduce within the problems. Some kids find this the easiest way for me to do it. Others would like to go like this. 1 pi over 6, 2 pi over 6, that reduces, keep going. 3 pi over 6, 4 pi over 6, that reduces, 5 pi over 6. And I'm going to kind of just explain this 2 ways. 5 pi over 6, 6 pi over 6 would be right here, which is, let's go get those pi's on there. I like to usually do those first. My quadrantals, please. First I'm going to say that's 0 radians. Halfway around is pi radians. And then this is halfway up here would be pi over 2. So I forgot, I like to do my quadrantals. 1 pi over 2, 2 pi over 2, 3 pi over 2 at the bottom. 4 pi over 2 reduces to 2 pi. All right, let me get back now to my radians. So I had 1 pi over 6, 2 pi over 6, but it reduces to pi over 3. 3 pi over 6, The next one would be 4 pi over 6. That's 2 pi over 3. So now do you see where I can do 1 pi over 3, then 2 pi over 3, then 3 pi over 3, 4 pi over 3 though? Wait, where's that going to be? That's all the way down here because it would be 60 degrees away. Okay, so I'll go back through my pi over 6s for those of you who will be better with going by 30s. 1 pi over 6, 2 pi over 6 reduced to pi over 3, 3 pi over 6, 4 pi over 6 reduced to 2 pi over 3, 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6, which would have reduced to 4 pi over 3, 9 pi over 6 reduces to 3 pi over 2. Next one would be 10 pi over 6 or 5 pi over 3. You see that after 4 pi over 3 comes the 5 pi over 3 if you were doing it by pi over 3s. Okay, so I got 10 pi over 6, then comes 11 pi over 6. And if I hit 12 pi over 6, I'm back to 2 pi. All right, I'm doing red for this middle one. All right, that's going to be my pi over 4s. 45 degrees, you're going to memorize is pi over 4 radians. 1 pi over 4, 2 pi over 4 would be up here. Reduces to pi over 2. 3 pi over 4, bang, label it. 4 pi over 4 would be pi. Then the next one, 5 pi over 4. 6 pi over 4 at the bottom. So the next one is 7 pi over 4. And 8 pi over 4 would give me 2 pi. So we are just cutting it up into fractions, okay? Degrees. All right, now we're going to, oh my goodness, look at that. This looks horrible. Now let me explain that. I didn't draw, you see how your 30 degrees is actually right there? Your 45 degrees is really that angle. Your 60 degrees is really going to there. Okay, that's all we need to look at. We are also going to label all of these locations, okay? And we're going to do it on here. After the break, you got this, yeah, you're going to flip. It's in there. Yep, back of where you were. See this lovely thing? We're going to fill it in with all of that, except for none of these lines in here. All right, so we're going to go around. We're going to learn to label everything. And the first step, though, let's work with a little bit of color and make this pretty. So I'm going to take black for my quadrantals, which would be this diameter and this diameter. You can use any color you want, but I'm going to need 3 colors in between if I want to color it. If anybody wants some highlighters, I've got some up here you can borrow if you don't have a color you'd like. I got some in here too. 3 would be the best because we got how many reference angles do we have in our quadrants? See those 3? That's going to be the ones that we want maybe colorful. It's real easy to see where your reference angles are, and I hope you'll start to understand better the little bow tie thing I told you about. Remember this? Okay, and I said all your reference angles are in the bow tie. Okay, I told you this. This was in the last lesson. All these are the reference angles. So that will have the same reference as, let's see, I'll show you. I'm going to do green for my 30s. That'll be on this diagonal. And in quadrants 3 and 4 on this diagonal. Now I'm going to use red on the 45s. You could use pink maybe. It would be smack down the middle of those quadrants. And then I was going to use blue for my 60s. Oh, I skipped a circle on your pictured thing, didn't I? And you know what? Let's not worry about it. We'll be in better shape for time. If we want to fill it in, I can, but oh, I believe, okay. Everybody's got this, once everybody's got this colored on the back, I think I'm going to go back there for a minute. Now I know why. I know what I'll do. Here's why everybody suggested you get the rulers. Okay, for whatever reason, I don't have that picture in this my smart here. I'm going to take those off of there. If you want to connect those points on that bottom circle, so once you got that colored on the big circle, will you go back a page? I forgot about that bottom one. It tells you to label something else on there. What's it say to label? Yeah, label each X, Y coordinates. Okay. You may not want to make these parentheses in ahead of time because of how you write. I'm just giving you a hint that these are going to match. Okay, now I'm going to show you where to get them, and I'll finish that later. All right, if you're at 0 degrees, think about this having a radius of 1. This would be the point 1, 0. Your points are written X, Y, and I'm going to tell you now that X is the cosine and Y is the sine. Got to get that down right away. So, how am I going to find these points, you say? Well, first let's talk about the quadrantals, and then I'll explain about the ones in between. 1, 0 is the location on a circle of radius 1. Would be this location, would be 1, 0. If the radius is 1, this would be at 0, 1, at 90 degrees. At 180, you'd be at left 1, so negative 1, 0. And at 270, you'd be at 0, negative 1. Okay. So you can tell the cosine of 90 is 0, right there. The sine of 90 is 1. The cosine of 270 is 0. Sine 270 is negative 1, etc. That you're going to get that all off of here now. All right, now we're going to get the new ones. You have seen special right triangles. I'm going to start with 45, 45, 90. Yes. Okay. You can watch the end of it if you want. I'll post today. Good luck. Okay, if you're, what did you say? Anyway, go Harlem. All right, the sides, if these were 1 and 1, what would be the hypotenuse? 1 square root of 2, or just the square root of 2. Okay, so from that, let's get the sine and the cosine. If you go to 45, the cosine would be 1 over the 1 over the square root of 2, right? But you're not allowed to leave radicals in the basement, remember? So rationalize that quick would be square root of 2 over 2. That's, and guess what? If you're doing a 45, 45, 90, the sine and the cosine are equal. The cosine would, if it's 1 over the square root of 2, and so is the sine. Opposite over hypotenuse, 1 over the square root of 2. So these match. All of these red ones match. But if you're in quadrant 2, x is negative and y is positive. If you're in quadrant 3, they're both negative. If you're in quadrant 4, the cosine or x is positive and the sine is negative or y is negative. Right now I'm going to do my 30, 60, 90. I'm all done with 45 reference. $30, 60, 90, special right triangle. Let's just say the short leg is 1, the hypotenuse would be 2, and the long leg would be the square root of 3. 1 square root of 3. Let's do it from there. Ready? Cosine, 30. Go to the 30 degrees. Adjacent over hypotenuse. Square root of 3 over 2. Sine 30. Opposite over hypotenuse, 1/2. Let's just fill in all those green ones now. This would be negative square root of 3 over 2, 1/2. This one would be negative and negative. And I forgot the negative sign on my 1/2 there, excuse me. And this would be positive square root of 3 over 2, negative 1/2 in quadrant 4. Okay. Let's see, I'm going to do all the 60-degree reference or pi over 3s. Back over to your special right triangle. 60 degrees. Cosine would be 1/2 adjacent over hypotenuse. The sine would be opposite over hypotenuse, square root of 3 over 2. And all of those are the same, except for the sines. So negative 1/2 square root of 3 over 2 in quadrant 2. Both negative in quadrant 3. 1/2 would be positive in quadrant 4, and the square root of 3 over 2 would be negative. Okay, there's yet another way to memorize this, in that if you know the pi over 3 or 30, pi over 6 or 30 degrees, what happens with the values for the 60 or pi over 3? Look, they just flip. So memorize this, and then take that and flip it. The first one and flip it to get the third one. And then just mimic them in every quadrant, making sure you pay attention to positive or negative. You just have the answer to 1, 2, 3, 4, 5, 6. You have a lot of answers right here for cosine and sine of a bunch of things. You can also do tangent. Why? Don't forget that tangent is y over x. You've got the y and the x. You can write the y over the x and simplify. So let's move on to the entire unit circle. All right, here we go. We're going to fill the whole thing in. It looks ominous. It's really not. So personally, I've always felt that starting with my quadrantals just got me going. And then I start with the next one, whatever order, whatever works for you. But we do know this is 0 or 360. In radians, it's either 0 or 2 pi. Okay, let's go halfway around because that makes half of 360, 180. and half of 2 pi would be pi. I'm trying to show you a pattern for filling it out. So then we go, half of pi would be pi over 2, and half of 180 is 90. So that's at the top. Then I'm going to go 1 pi over 2, 2 pi over 2, 3 pi over 2 to get the bottom, 270. All right, and then I'm going to fill in the points quick. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Do our pi over 4s now. All my red ones. Go to the middle ones, which are 45 degrees. .45 in radians is pi over 4. Square root of 2 over 2, square root of 2 over 2. All the red ones are going to match that, except we got to figure out how to label it. So to get it labeled, because remember, you're going to do a whole entire blank circle like this for a quiz. And you'll be able to do it after you practice it. I'll give you a few more blank ones later before we do it. Yep, it's just this is a quiz. You got to fill the whole thing out. Okay, so this is a preview of a quiz. Anyway, when's that quiz? After break. No, after break. You don't want it tomorrow. I don't want to do that to people. All right, 1 pi over 4, guys. Ready? Let's count around. 1 pi over 4, 2 pi over 4, 3 pi over 4. 90 plus 45, 135. Sine is negative square root of 2 over 2. That's the cosine, excuse me. And the sine is the square root of 2 over 2. Okay, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4. 180 plus 45 is 225. The signs are both negative and they're both the square root of 2 over 2. Sine and the cosine. $225 plus 45 would be 270. The next one would be 270 plus 45, which is 315. And it is almost that. It's only 311 right now, though. All right, 5 pi over 4. Sorry. 5 pi over 4. 6 pi over 4. 7 pi over 4 is where we are. Square root of 2 over 2 for the cosine, negative square root of 2 over 2 for the sine. I hope you're hearing me say cosine sine. Do you want to get that in your head? That's the point. The cosine of that angle, the sine of that angle. Ready? Let's do our pi over 3s, which is 30 degrees. Okay, if you need to grab yourself a special right triangle at that moment, do it. Short leg 1, hypotenuse 2, long leg square root of 3. Okay, if you've forgotten, the cosine is adjacent over hypotenuse, square root of 3 over 2. And I'll give you a little hint. Square root of 3 over 2 is bigger than 1/2. You're further to the right. That's why the x value is larger. Okay. The sine is opposite 1/2. You want to just do all the green ones now? Because some kids like to go to the next, like count by pi over 3s. I don't know why I wrote pi over 3. You know why I did? Because I do the same thing as kids do sometimes. 30 and 3 gets in my brain. It's supposed to be pi over what? Sorry. My bad. Huh? Well, just put over it like I just did. Look, I went like that, right on top of it. I didn't erase. Sorry. Sorry. I can't believe I did that. I really try to not make that boo-boo. Why did I say, well, Pi over 6. Yeah, hopefully you learn from that. Don't associate those numbers. Ear. Okay, 1 pi over 6. All right, do you want to do this blue one for 2 pi over 6? All right, then I won't. Okay, if it reduces, skip it. Okay, that's what you would do. So I've had it that way many years. 1 pi over 6, 2 pi over 6. Keep going. 3 pi over 6, 4 pi over 6, 5 pi over 6. 5 pi over 6 doesn't reduce. All right, let's just keep on going to get those things done. 5 pi over 6, 6 pi over 6, 7 pi over 6 doesn't reduce. Write it on there. 8 pi over 6 would reduce. 9 pi over 6 would. 10 pi over 6 would. 11 pi over 6. And if you had 12 pi over 6, you're already at 2 pi. All right, fill in the angle measures. If you wanted to go by 30s, I think that would be 30. If you go 30 back from 180, it would be 150. I can teach it that way. Coming down from 180, 30 would be 210. Going back from 360, 30 would be 330. And then all the points match except the signs change for the quadrant. So this is negative square root of 3 over 2, 1/2 in quadrant 2. They're both negative in quadrant 3. And in quadrant 4, the square root of 3 over 2 is positive, and the negative 1/2 for the sign is negative. So I'll let you guys dictate a little to me on that. I didn't do it quite the same way last hour. All right, here we are. Pi over, are we ready? Pi over 3. Let's just flop pi over 6's points. That's all you need to do. Switch it. 1/2 first for the cosine, square root of 3 over 2 for the sine. We came up 60 degrees. Okay, if you want to go for reference angle in the next quadrant, go back from 180, 60 degrees would be 120. 1 pi over 3, 2 pi over 3. We keep going. Let's go every 60 degrees. 1 pi over 3, 2 pi over 3. 3 pi over 3 would be at pi. 4 pi over 3 would be down here. And 5 pi over 3 would be the last one, because you're going all the way 60 degrees. All right, all the points are the same, except the sign changes per the quadrant. We're done. Oh, I didn't do the degrees on my last one. Okay, 60 down from 180 would be 240, and 60 down from 360 would be 300. Good way to think about it, to keep on thinking reference angles from the x-axis. All right, how do we use this? Guess what? Once you quiz on this and you fill this entire thing in, you're going to get a copy to use, basically for notes, like all the time. No. No. Oh, I guess you could. No. I will give you a reference sheet that you get to use, and no, you can't write on it. I got to be honest with you. It's going to be consistent across the board. So it's usable on the final, but unit circle, you get one on the final too. But you need to know it, and I got to be honest with you, when you get to calculus, Ms. Gupta wants you to know this stuff by heart. For sure. All right, that's just another picture of what we just got through doing. So here's how you use it. This is really important. Got a game? Oh, good luck. Volleyball, yay. Go boys volleyball. All right, find the reference angle. This was not, if it's in radians when you get it, your answer better be in radians. What is a reference for negative 3 pi over 4? Look at your unit circle. Where would you be? The positive coterminal angle to that would be right there, which would have been, come around to your quadrant, 1 pi over 4. Aren't you at 5 pi over 4 on your unit circle? Okay, the reference angle for any pi over 4 angle is 45. Pi over 4. You got to get it straight that 45 is pi over 4. Pi over 4 is 45 degrees. You need to know that by heart. Okay, that means the reference angle is 45, isn't it? Because what would this angle be right there? Okay, that's what I'm getting. And I drew it in terms of pi. In terms of radians, I should have said, not in terms of pi. All right, 2 is negative 240. Where does that put you if you went the positive direction? At 120 on your unit circle. What's the reference angle, which is with the x-axis? X? It would be completely marked wrong. You cannot have a reference angle that is negative. No negative reference angles, always a positive. I'm very glad you asked that. Can't be negative. A reference angle is always positive, and I told you that. Okay. Sound like the quizzes might not have gone so well? Okay. All right, what's this right here? Where are you at 5 pi over 6? How many more degrees to get to here? Actually, think about it this way. If you're at 5 pi over 6, what's it take you to get to pi? That's the reference angle. Okay, what's it take you to get back to the x-axis on this one? That's the reference angle. Pardon? So, you're going to have a lot of the same answer yeah, for reference angles. Yep. Oh, we don't want to look at that. All right, convert each degree measure into radians, each radian measure into degrees. Some of these are right on the unit circle. This should be, think about it, it's once around the circle backwards. Six, negative pi over 3. Well, that would be where your 5 pi over 3 is, isn't it? Negative 60 degrees then. Okay, think about where negative pi over 3 is. It's here. It's by your 5 pi over 3 on your unit circle. Okay, you're using your unit circle to help you right now. 5 pi over 3 is a reference of 60 degrees. That means you went negative 60. Okay, 11 pi over 6 would have a reference of pi over 6. That Oh, what was I supposed to be doing here? I need to get back to degrees. This would be negative 60. Oh boy. Okay, what is this if I went? No, it is negative 60. That's fine. This one I gotta fix. I was thinking reference angle again. So 11 pi over 6, isn't that just 30 degrees down from there? That would be 330. Now, do you want me to show the conversion factor again? Remember, it's times 180 over pi if you're going from radians. You can get it from this as well. All right, 6 goes into 180, 30 times 11 times 30 would be 330. So if you want to do this one, you can multiply by pi over 180. Just use your conversion factor if you feel more comfortable with that. What do we got for that? You can go on your unit circle and look. Isn't that 11 pi over 6? Okay. And 270, you should know, is 1 pi over 2, 2 pi over 2, 3 pi over 2. And 120, if you can't remember, it's 2 pi over 3. All right, go look at your unit circle. Where are you? Tell me what's labeled at that spot right there, at negative pi over 3. Should be at your 5 pi over 3. What's the point? 1/2 is first, and the square root of 3 over 2 is second, and it is Negative. All right, which one's the sign? It goes cosine. That's the answer to this. You have to start thinking like this. You have to start looking at those points and looking at them and thinking the first number is the cosine, the second number is the sine. Cosine of theta at negative 135. Well, that's a reference of 45 degrees. The point there is the square root of 2 over 2, the square root of 2 over 2, and they're both negative. So what's the cosine? Negative root 2 over 2. All right, go to where you are. That is at 330. So that's a reference to 30 degrees. I'm thinking you're at your 5 pi over 3. No, sorry, 11 pi over 6. All right, but what the point is we need to know the point there. Isn't that negative, wait, square root of 3 over 2, negative 1/2? Yes? Okay. What one do I want? I want the tangent. You got to remember the tangent is y over x. So we got to take the y, or the sine, negative 1/2, over the x, square root of 3 over 2. Now, how do we simplify that? You certainly can't leave it like that. So you multiply by the reciprocal, and the 2's cancel out, and you get negative 1 over the square root of 3, and then you have to rationalize it. You multiply top and bottom by the square root of 3 and tell me the answer is the negative square root of 3 over 3. That's about as complicated as it gets. Square pi over 4, we want, that's square root of 2 over 2, square root of 2 over 2. They want the tangent, which is y over x. Well, these are identical, so what are you going to get? Okay, how are we doing? You're going to look on your unit circle, find the point, and decide whether you're doing cosine, sine, or tangent, or whatever it is. You get any of them off this now. 15, negative pi over 6. That point there is okay. We have to do sine over cosine. Negative 1/2 over square root of 3 over 2. All right, now our answer is going to be negative 1 over the square root of 3, but we have to rationalize it to negative square root of 3 over 3. Oh dear. Okay, now we already did 330. Isn't that where we are right now? Right, yeah. So what's the cosine? Square root of 3 over 2 positive. Yep. Okay, now it doesn't give a picture, so you might want to draw one if you need to. Cosine 300. You can go find 300 on there, and you could look at the point. I'll just remind you what that would be. It's going to be 1/2 negative square root of 3 over 2. Which one is it for cosine? First or second? The cosine is the first number, the x. That'd be 1/2. Sine 300, then negative square root of 3 over 2. Tan 240. I got a 50-50 guess. It's either 1 or negative 1. Figure it out. What quadrant are you in? If you went negative 240, you go up to quadrant 2. Right? All students up. Tangent's negative here. Oops, negative 1. It's hard to write square root of 2 over 2. $270. Oh, I guess we'll write 270. That's at 0, negative 1. We have like 4 minutes. You're all done. Oh, you gotta go early. Okay. What is the sign? It's the second number, so this would be -1. -7 pi over 6. Positive 7 pi over 6 is in quadrant 3, right? This takes a little different thinking in your brain here. You can always convert to degrees if you want to get it there faster, but if positive 7 pi over 6 is here, right? Oh, sorry, it's right there, right? Okay, then negative is going to be here. You're going to be in quadrant 2. The sign there is positive, so your answer should be positive. What's the point there? Pi over 6 reference. Okay, okay, so the sign is the y part, it's 1/2. And -225, positive 225 is in quadrant 3, -225 is in quadrant 2. Okay, tangent, all students, tangent's negative in that quadrant, so this would be -1. Now, how do I know it's -1? Maybe I'm not explaining enough. This is negative square root of 2 over 2, square root of 2 over 2. If you put one over the other, right? That's how I'm getting it. Oh, of course. Couple more. Think you got the idea? You're looking at the x part of the point at -30. Isn't that point? The x part is square root of 3 over 2. Okay, -45. Oh, now you got to do the secant. The secant is the reciprocal of what? So I'm going to think, what's the cosine there? That would be square root of 2 over 2. So this is going to be, actually, that's 1 over the square root of 2. It's actually the square root of 2. Now, I know that because I've had experience, so I'm going to explain it. Okay. If you take that and flip it over, 2 over the square root of 2, and you had to rationalize it, you would have to multiply by the square root of 2 top and bottom, and then your 2's cancel out. Otherwise, remember it was 1 over the square root of 2 in the first place? If cosine is 1 over the square root of 2, then the secant is the square root of 2. You can do it off the triangle too. But know what sign it is there. All right, good luck on your assignment, which is page 19. By the way, it's not a book assignment. It's a worksheet. You need to do it. So you know what ones you need to ask me tomorrow. Have a nice evening.